Hi, welcome to this lesson on trigonometry double angles. We want to solve for x where it's between 0 and 360 degrees in this question 2, where we have the original equation 2 sine squared x minus 2 cos squared x equals 1. So, as a force of habit, let's start writing all the double angle formulae that we know and see how we can use it. So, sine of 2x is 2 sine x cos x. And then cos 2x had three variations. The original one, cos squared x minus sine squared x, 2 cos squared x minus 1, and 1 minus 2 sine squared x. So I see squared terms and cos and sine. So if I can try get it in this form, then I can simplify it. So I'm going to first divide everything by 2. So I get sine squared x minus cos squared x, and 1 divided by 2 is a half. Now we're not quite there yet, because look here, this is cos squared x minus sine squared x. We have sine squared x minus cos squared x. So if I multiply both sides by -1, what's going to happen? Okay, so I'm going to get negative a half on the right, and now if I multiply that negative half in, I'm going to get positive cos squared x and negative sine squared x equals negative a half. Now from our double angle formulae, that is exactly cos of 2x equals negative a half. Okay, so now we have a standard trigonometric equation which we can solve for. So let's get up our cast diagram. So where is cos negative? That's in the second and the third quadrants. So let's work out our reference angle first. So cos inverse of positive a half for your reference angle is 60 degrees. So in the second quadrant, it's going to be your angle 2x equals the reference angle 180 degrees minus the reference angle. So that's going to be 120 degrees plus k times 360 for the period of cos. And then if I divide both sides by 2, I get x equals 60 degrees plus k times 180. So the period has changed here by a factor of 2, so it's now 180 degrees. And then quadrant 3, the angle 2x must be 180 degrees plus the reference angle, so 240 degrees, plus k times 360 degrees. And if I divide both sides by 2, I get 120 degrees plus k times 180 degrees, where k is an integer. Okay, so these are the general solutions, but we want specific solutions for when we have x between 0 and 360 degrees. So for the second quadrant, if I put k equals 0, I get x equals 60 degrees. That is valid in that domain. K greater than or equals to 1. At 1, I'm going to get 60 plus 180 is 240, which is in there. And if I add another 180 to that, well, I'm already outside the given restricted domain. Then less than or equals to -1, there's going to be no applicable solutions because you're just going to get negative values. And then for here, if I put k equals 0 in the third quadrant, I get x equals 120 degrees, okay, as a first solution, which is in there. K greater than or equals to 1, I'll have 120 plus 180 is 300. And then adding another 180 will just be outside the domain. And then k less than or equals to -1, well, those are going to be negative solutions, so not applicable. So again, we have 4 possible solutions, and we can substitute them in to check that they satisfy the original equation. So I have 2 something squared minus 2 something squared. Okay, so it's going to be sine of the angle and cos of the angle. Okay, so that's how we get the squareds for sine squared, cos squared. We've got to write the ratio sine and cos inside brackets and then square it on the outside. So the first angle we found was 60. So let's put 60 in here. Okay, then we get 1. And that was the right-hand side. Perfect. Then the next one we found was 240. So let's plug that back in there. And we get 1. Awesome. So that works as well. What about 120? So let's plug that in there. Okay. 120. We get 1. Awesome. And then the last solution we found was 300 in that restricted domain. And that will give us 1. Awesome. So these are 4 valid solutions in that restricted domain that satisfy the original equation. Awesome. I'll see you in the next one.